yours is ACM 0, right?
Mm.
1 minute, almost done. Ah.
It's like a melt ship.
Last.
Do you need the script?
Oh, no. Is that recording?
Yeah.
Okay, start.
And this as well. And this also.
Okay.
Hi everyone, my name is S. Karthik and I'm doing my final year mechatronics in Shastra University, India. So now my final year project is based on Giraffe Robot. A Giraffe Robot is an extension of human presence developed by Giraffe Technologies AB in Sweden. So this robot is mainly made for assisting elderly people and handicapped people. So this is just like a Skype technology, Skype video conferencing. The user who is far away from this place can actually contact the person who is here using Giraffe Robot. So with this camera, we'll be recorded, and then through the monitor we can see the other person who is far away. So he can control this Giraffe Robot using his personal computer, and which is actually helpful for elderly people. So now, what is our role in this project? So we have actually incorporated ultrasonic sensors and accelerometer, so that Giraffe Robot would perform even better, efficiently and in a smarter way.
Hello, my name is Vishnukant and same profile as Karthik, and basically we have used 9-axis motion sensor which is assembled to Arduino Uno. This lower part is Arduino Uno and this upper part is 9-axis motion sensor. 9-axis motion shield. Okay, what it does, it actually gives two types of output, that is orientation and inclination. There are 4 types of orientation, that is forward, backward, left, right. In forward orientation you wanted to move the Giraffe Robot forward. In backward you wanted to move the giraffe backward. Similarly in left, right. And the coming to inclination, in each orientation you can change the inclination. This is responsible for changing the speed in that orientation. Let's say for example in forward orientation you want to move the robot fast, you can put it in more inclination. Similarly in back, left, right. And coming to motor control part, this Giraffe Robot has 2 types of systems inside it. It has on-board computer and low-level board, that is microcontroller. And the on-board computer we have installed Linux where ROS system is running, and the low-level board which has Atmega 644 microprocessor, and we have customized Arduino IDE so that we can use that Atmega 644 in Arduino environment. And basically it has motor drivers, H-bridge, where you can control the speed and direction of these motors. And by the way, this is differential wheeled robot where we can power the wheels separately, left and right. It's actually you can use Arduino IDE environment for controlling that processor. You can actually change the outputs of those peripherals of. And this accelerometer publishes 2 types of data.
Yeah.
And the data is how much the left wheel should move and how much is the right wheel should move.
So from this board you publish directly
Yes.
motor velocities.
And in that board,
Yeah.
that subscribe the same topic,
Yeah.
left wheel and right wheel,
Okay.
and give it to that processor,
Mhm.
where that processor is connected to driver,
Okay. Yeah.
motor drivers. And we would at a time that motor controller board publishes the data of encoder
Mhm. And you observe it on the same
on
the
my
same
lap.
computer where you have.
Yes, I can see it on both the computers.
Yeah. Yeah. Sure.
These there are 3 ultrasonic sensors.
Mhm.
I have placed 2 of them at the front and 1 at the back.
Yeah.
So they are mainly to find the distance of obstacles.
Okay.
So in case the robot moves and there's an obstacle, the ultrasonic sensor will let you know the distance of obstacle from the robot, so that we can program it so that it changes the direction accordingly. If this will publish the data, and the other program will subscribe to the data, and using the data you can control the robot's movement.